Hello everyone, welcome back to JDCodebase. Today is day 32 of my LeetCode 75 study plan series, and today we are solving LeetCode number 2130, maximum twin sum of a linked list. Today this is a very interesting linked list problem because we will learn two different approaches. First one is the brute force approach using an array, and second one is the optimal approach using the slow and fast pointer and linked list reversal. So let's start. First, read the problem statement. In a linked list of size n, where n is an even, the ith node 0th index of the linked list is known as the twin of the n minus 1 minus ith node. And for example, if n is the 4, then 0th index is the twin of the third index, and node 1 is the twin of the node 2. So these are only nodes with the twins for n is equal to 4, and the twin sum is defined as the sum of node and its twin. And we are given the head of a linked list with the even length. Return the maximum twin sum of the linked list. So let me simplify this problem statement. We are given a linked list whose length is always even. It's clearly mentioned whose length is always even. For every node, there exists a twin node. Now, twin of index I is by n minus 1 minus ith. Means if you can get the twin index by this formula. If 0th index is this, then you get the twin by using this formula n minus 1 minus I. And we have to find the maximum twin sum. A twin sum is the value of current node. Like here this says 0th index, then the third index. Here twin sum is the 0th index plus third index, and 1 index plus 2 index. So these are the two twin sums of the both indexes, and we have to finally return the maximum twin sum. Let's see some example is like 5 4 3 2 1, 5 4 2 1, and output here is the 6. Let's understand why this output is the 6 here, because if we see the indexes here 0 1 2 3. Let me clarify one more thing. In the linked list there are no index system. I am just assuming the index system here just for my convenience. There is no index system. You cannot access any element in a linked list by just by square bracket and that index like an array. I'm just assuming it for simplicity. So twin pair here are the 0 and 3 and 1 and 2. So if we sum the both, like 5 plus 1 6, 4 plus 2 is 6. So maximum twin sum here is 6. So our answer here is the 6 here. Now in a linked list, as I already said, we cannot directly access the last node. Means if I in an array form, we can access directly by first pointer and last pointer and move both inwards. So 0 to 3, then 1 to 2. But we in linked list we cannot directly access that last node or indexes. But in an array we can access any index easily. So first let's convert the linked list into an array form. Then we can use a two pointer approach, and one pointer start from beginning, one pointer start from the end. Then calculate all the twin sum and store the maximum value and move the inwards. So let me write the code here first. Yes, so let arr is a blank array. First I initialize this. Let temp is equal to head. I just copy this and it runs while the temporary is not equal to null, means until I reach the end. Array dot push temp dot value, and temp equal to temp dot next. So let initialize this first is equal to 0, let last is equal to array dot length minus 1, and let maximum sum is equal to minus infinity. So start a while loop. it runs until the first is always smaller than last, means until it does not cross. Calculate the maximum sum by math.max, sorry, it's math, JavaScript math method, and we have to get the maximum sum by compare the both value maximum sum plus array of first plus array of last. I get the sum from this and compare the values, and every time we have to increase the first pointer and decrease the last pointer because we have to move the inverse, both of them move to the inverse. Return the maximum sum. So let me tell you one explanation is like first I create an empty array. Let here is an empty array. Then this will store all the node value in this. Next we create a temporary pointer. Let temp is equal to head, and now traverse the linked list. How to traverse? While by using the while loop, it runs until the temporary not equal to null, and we just push every value into an array dot push temp.val, and move to the next node, and temp is equal to temp dot next by using this, and now means I get all the values into an array. Now I just create the two pointers, first and last. First pointing to the first start from the beginning and last start from the end, and initialize the maximum sum by minus infinity, so we can easily get the maximum sum, and start a while loop. It runs until the first is doesn't cross the last, means first is smaller than last, and calculate the maximum sum every time by using the math.max method. Just give the maximum value and array of first plus last, and take out, and move the both pointers by first plus plus, last minus minus, and in last finally return the answer, that is the return maximum sum. So by this I get the answer. Let me run this solution. Yes, it accepted. There is no issue with this, and this solution is working perfectly fine, but there is an issue. Issue is like time complexity for this solution is the big of n. That's totally perfect because single means a while loop runs only, nothing special nested or loop, and but space complexity here is the big of n, and because it uses extra array space. And can we solve it without using an array? Yes, we will use a famous linked list pattern for this. For that, first find the middle of the linked list, then reverse the second half and compare the first half and reverse the second half, and this automatically gives us all the twin pair. This one is sound confusing. Let me show you what I'm saying. Like I have this 5 4 3 2 5 4 2 1. Let me erase this. Now I have this linked list 5 4 2 1. So first find the middle, because we cannot access the elements directly by index, so I just get the middle element here by using the while loop, slow and fast pointer using, and this one is second half, this one is the first half. I get the middle point at the 2 here. Just reverse them. 1 is come at this place, 2 is come at this place. Now initialize the 2 pointer, 1 pointing to this, 1 pointing to this. This one is a separate form. 1 and 2 is a separate, 5 and 4 is a separate. 5 4 2 1 is a completely separate. Now again run a while loop by using this. Take the value from this, take the value from this at a time. 5 plus 1 6, 4 plus 2 6. By this I get the maximum sum, and it runs only till this second array, this second linked list, and I get the answer by using this. Let me write the code, and this takes the means we have to find the middle index, middle element, and reverse the linked list. So it's a totally has a very varieties of solving. So let me first write the let slow is equal to head, let fast is equal to head, start a while loop, it run until the fast and fast dot next is not reaches the end, and slow is equal to slow dot next. Slow pointer run one step at a time, and fast pointer run two pointer at a time. Fast dot next dot next. And by this I get the element the means I get the middle element by slow. Means slow is always at the middle by this method. Now let's initialize the two thing. One is the previous, that is the null. Let current is equal to slow. As I said one thing, this one is a separate 1 and 2. Now by using this I am pointing to this. This one is used by this, let current is equal to slow. Now this current is pointing to this one, not 5 or 4 or 2 or 1. These are pointing to this, means it start from the 1. It skip 5 and 4 here. Means it's a separate linked list here. Start a while loop until the current reaches the end, and let next node is equal to current dot next. It's just a temporary node so that we can link that remaining element. Means by when we are reversing, we are just breaking the previous link and joining the new link. And by this current dot next is equal to previous. By this line I am just pointing 1 means 2 to 1, and move the pointers further. Previous is equal to current, and current is equal to next node. And now I have these values. Let first is equal to head, let second is equal to previous, and let maximum sum is equal to 0. Run a while loop, it runs until the second, and maximum sum is equal to the math dot max. It is totally same the previous one, maximum sum, but this time we have to calculate by first dot value plus second dot value, and move the both pointer forward by first dot next, and second is equal to second dot next, and return maximum sum. So let me simplify this, explain you one more time. First we create the slow and the fast pointer, the by that pointing to head. Then we start a while loop, it move the slow by one step. Slow is equal to slow dot next. This is how it reverses the linked list. And fast is equal to fast dot next dot next. So this help us to find the middle element. Now I get the middle element, and middle element always come to the slow pointer. Now current I just means we have to reverse the second half. Means I get the 2. Now we have to reverse this 2 and 1. For that I just initialize the 2 pointers. Previous is equal to null, and current start from the middle, and start the while loop. It runs until the end, means they are pointing this 2, and 2 and 1 only we have to reverse. So we just have to store the next node current dot next, and reverse the link by current dot next is equal to previous, and previous is equal to, means we just move the pointer forward. Previous is equal to current, and current is equal to next node. And after the loop finishes, previous become the head and of the reverse list. So we create the 2 pointers again, first and second. First pointing to the head, first pointing to this 5, and second pointing to this 1. And maximum sum is always 0, and traverse the both half and it runs means by this, and calculate the maximum sum for this math.max, first dot val, second dot val, and store the maximum value here, and move the both pointers first and the second by first dot next, second dot next, and return the answer maximum sum. So let me run this solution. So yes, it accepted and perfectly working. So for the brute force solution, converting linked list into an array and use the two pointer and calculate all the twin sum, store the maximum answer we did. And but for the middle optimal solution, we find the middle element and reverse the second half and compare the first half and the reverse half, and store the maximum time sum. So here time complexity is the big fan for this optimal one, and space complexity is the big one because we will only use the few pointers. This is the best solution. And that is for day 32 of the LeetCode 75 study plan. Today we learned twin sum concept, array and two pointer approach again, and the slow and fast pointer technique, and reversing a linked list optimal big of one space solution. If you found this video helpful, please hit the like button, leave a comment below, and subscribe to JDCodebase for more LeetCode solution every day. Thanks for watching. I'll see you in the next video.